Hello, everyone. So we're going to move into the section number 2 in Unit 1. So in this section, we're going to cover the material from Chapter 2 in your textbook. And also in this section, I am planning to discuss about the motion of the object in one dimension. So we all know that the motion of the object is obvious part in our day-to-day life. Right? So moving of objects, we call it as mechanics. So now mechanics have two parts. One is we call it as kinematics. Kinematics means how objects move. And the other part we're going to move later on, dynamics. Dynamics means why objects move as they do by involving with forces and some other physics principle. So now in this section, I'm planning to go to the one-dimensional translational motion. So now what is one-dimensional translational motion means? Translational motion means object is moving without doing rotation. One dimension means it will be this your horizontal dimension or it will be your vertical dimension, right? So, but translational motion, that means no rotation. This object is moving without doing rotation. What is the rotation means? This object moving, doing the rotation and then moving. That will be including of rotational and translational motion that we're going to come back to that later on the semester. But here we are working with one-dimensional translational motion only. So now the concepts that we're going to discuss in this chapter basically belong to the studies found by scientists Galileo Galilei and Isaac Newton, and also there are many other scientists involved with those, but those two scientists are the main scientists who involved with the concepts that we're going to learn this section, next section, and couple more sections also. And now let's move into your textbook first. I mean your Blackboard page first. Okay, so let me share the screen first. Okay, so as I mentioned, it will be your chapter 2 materials that we're going to cover, and there are a lot of information inside this chapter, but we're going to discuss briefly all the informations. Okay, so now let's move into the presentation. So we're going to talk about the kinematics, that means one-dimensional motion. Okay, so let's move into the type of motion. So kinematics describe the motion of the object by ignoring external agent that might cause or modify the motion. So that means, as a simple example, if your object is moving, if there is friction, friction will do the external force or something that will disturb the motion. So in that case, that is not kinematics. Kinematics means basically describe the motion of the object without any external disturbance to the motion. Okay, so now motions, as I mentioned, divide into basically 3 parts. One is the translational motion. Translational motion, as we know, it is moving on translational without doing the rotation. So simple example is your automobile. So you just move in translational motion. And rotational motion will be moving object with the rotation. Simple example is spinning the earth. Earth is keep rotating. Right? And vibrational motion is another thing. As a simple example, you can think about the spring pendulum, that you have a spring, that spring will do the back and forth motion, that is called it as the vibrational motion. So we're going to involve with those all the motions throughout the semester. Okay, so right now we are in translational one-dimensional motion. So now in addition to that, everything that we discuss in this your class is basically the objects that we call it as the particle model. That means we're going to work with the particle like a point-like particle or the object that has a very small in size and also maybe very small in mass. So we're going to just consider the point-like objects throughout your class. Okay, that is called it as the particle model. Okay, so now next step is actually all the measurements that we are taking, all the physical quantities that we are talking is given with respect to some reference frame. So because of that, knowing the reference frame is important, right? So now everything that we are measuring right now, velocity, acceleration, those things, distance, we are measuring with respect to Earth, and we are saying Earth is at rest. Although Earth is spinning and moving around the sun, we already know that, but we're going to measure everything with respect to the Earth. That means we're going to take the Earth at rest, right? So now I think this example will explain you why it is important. We'll see there is a train moving with 100 kilometers per hour, and friends inside the train walk in front direction 5 kilometers per hour. So now find the speed with respect to the train, find the speed with respect to the ground. So these two things are two different things. So there is a train, right? So train is moving, velocity 1000 kilometers per hour. And there is a person inside the train, that is your friend, walking inside the train with the speed 5 kilometers per hour, right? So now it's asking friend speed with respect to the train. So now with respect to the train, your friend speed is just the friend speed, because respect to the train, that means train, you're going to think at rest, because inside the person, inside the train, the person feel only the person speed, right? Because of that, respect to the train means train is at rest. At that time, your friend speed is 5 kilometers per hour. Okay. But friend speed with respect to the ground, that means there is a third person sitting outside. You are watching the friend walking inside the train. So now we know that train is very high speed, and inside the train there is a person walking 5 kilometers per hour. So now this person outside, that is the ground basically, with respect to the ground, your friend has two speed. One is the train speed, other one is the friend speed. Then you need to add this up. That will give you the with respect to the ground. That means 100 plus 5 is 105 kilometers per hour. So you see that these two numbers are totally different numbers. Because of that, the reference frame is something that very important to mention that when we take the readings. Okay. Okay, so now let's move into our first concept in the chapter, displacement and distance. These two quantities are two different physical quantities. We call it in physics, right? So it's very easy to understand by thinking this way. So these both are measuring by using meters, because distance you use the meter ruler, measured it by meters, and this one measured by meters, same SI unit, right? But they are different quantities. Why they are different? Simple example, think from this diagram. So I have A and B. I plan to travel from A to B by using this blue direction. So that is, we call it as the displacement. Okay, but if I try to go somewhere, shopping somewhere else, and then go to the mall, and then go to the gas station, then I have the different path that I will take, this one, right? So that is what we call it as the distance. Best example that you can see, when you walk with your dog will follow the distance, you follow the displacement. That kind of difference is there. Okay, so in addition to that, in conceptually, displacement, we're going to call it as a vector, and distance, we call it as the scalar quantity. Scalar means only magnitude, there is no direction. Vector means there is a direction in addition to the magnitude. We're going to talk these informations in your next section in more detail. Okay, so SI unit is meters. Okay, so now let's move into the velocity. So speed is the first part. So speed, basically call it as the how far the object travel within the given time interval. That means distance travel divided by the time it will take. We call it as the speed. So that is the average speed. So now similar to that, velocity will be not the distance divided by time. Velocity will be displacement divided by time. Displacement divided by time, we call it as the average velocity. Now displacement will be final position minus initial position is the displacement. We always write this velocity equal delta x divided by delta t. Delta x is the displacement and delta x, anytime when you write something, change of something, in case change of x is delta x, that will be your final position minus initial position. That is what the displacement is. So now definitely units, you guys can see displacement divided by time, displacement measured by using meters, time measured by using second. SI unit will be meters per second for speed and the velocity both. Okay, so now let's move into some graphical thinking, because the visualization is always a good thing to get the understanding of the concept. So now I have the plot. Important thing is you realize what are the axes is. So you have y-axis here and you have x-axis here. So basically y I am measuring as a position or by using kilometers, and time as hours. That means this is basically showing me displacement as a function of time, right? So now you have in first part, you have a positive value going upward and then going downward direction. That is the behavior of your position as a function of time. Increase your distance and then you go definitely backward direction. Okay, so now what you need to think by using the velocity. Now what the velocity is? Velocity is change of rate of displacement. What that means? X final minus X initial divided by time. That means basically slope. This means slope. I already have it in here. Slope of the line in the position time graph, we call it as the velocity. That means you need to check your first slope. You see that the slope in here is a constant. If I need, I can calculate it. But slope in here is a positive slope, and also it is a constant because it is a linear graph, right? And now slope in here is negative. It is still linear, because of that it will be constant. Now if I plot the velocity as a function of time, what you get? So you will see until this point your slope is positive and it is a constant. That's why I have this, right? So after around 0.25 hours, I have the negative slope that is constant. That will show you the velocity plot with relation to your position plot. So these two are related to each other. Position plot can produce the velocity plot if you think about the slope of the position plot. Can I go backward? We'll say I am given the velocity plot. Can I go to the position plot? Yes, I can do that also, because if you take the area under the curve, you will see area in your first, we'll say 0.1 second, I have area in here. That means this value in here. And then you take the whole area 2.5, that will be this value, right? So that's the area under the curve will be given you the position plot. These two are connected each other, one to other, and the backward also. Okay, so now we discuss about the distance, displacement, speed, velocity. So now when you go to the automobile, that when you drive the car, your speedometer will give you speed, not the velocity. Speedometer does not give you the direction. It just gives you the magnitude, that is speed. And odometer in the car give you the distance, not the displacement. Okay. Okay, so now we are ready to move into the instantaneous velocity. So instantaneous velocity is the velocity that usually we call it as the velocity. So average velocity, we need the prefix average to say the velocity. Okay, so now instantaneous velocity is the velocity at some instance. We call it as instantaneous velocity. What that means is, if you take the change of displacement divided by change of time, if your change of time is very close to 0, that is, we call it as instantaneous velocity. In calculus, that will be basically derivative, that will be the slope, basically. Okay. So now, to understand your average velocity and the instantaneous velocity, I have two plots in here. First plot, I have constant velocity. That means instantaneous velocity here is still 40. Instant velocity at 0.2 hours is still 40. After 0.4 hours is still 40. What that means? That means instantaneous velocity is keep constant throughout this process, and that will be your average velocity. That means my left plot, when velocity is constant, average velocity is equal to instantaneous velocity. Okay, but what about the right plot? Right plot, if you take at this point, the 0.1 hour, I have the velocity around 50. Right? And then if you go to the 0.2 hour, I have the velocity around 30. If you go to the 0.4 hour, I have velocity around 20. So that means instantaneous velocities keep changing. Now, if you take the average velocity of this graph, will stay around 30 kilometers per hour. So that means in this case, in change in velocity case, average velocity and instantaneous velocity are two different quantities. Okay. Okay, so now let's move into the acceleration. So now acceleration is called it as rate of change of velocity. That means delta V over delta T is the acceleration, delta V over delta T. As soon as you write that, you can get the units. Delta V, we're going to measure it by meters per second, and you're going to divide by another second. That means acceleration units will be meters per squared second. Okay. So how to understand the acceleration? So we'll say I have a car, I start at velocity 0 at time 0, right? After 1 second, I have the velocity 15 kilometers per hour. So now I need to find the acceleration. So now your final minus initial velocity divide by the time give you the acceleration. That's why I have 15 minus 0. This is in kilometers per hour, divide by 1 second, right? So that's why I have acceleration, this one in there. So that is a positive acceleration because your velocities keep increasing, right? But sometime you may have a negative acceleration. Simple example in here, you start with velocity 15 meters second, but you're going to end up with the velocity 5 meters per second. That means you decrease the velocity. Because of that, if you calculate the acceleration by taking change of rate of velocity, you're going to get the 2 and the negative. That is called it as the negative acceleration. Sometimes people use it as a deceleration, but deceleration and negative acceleration is not the same words. Deceleration occurs when the acceleration is opposite direction of the velocity, right? Similar to here, opposite direction of the velocity. That you can call it as deceleration. But sometimes you can have negative acceleration, that is not deceleration. Okay, so because of that, be careful with these wordings. Okay, so acceleration also have instantaneous acceleration, that will be the acceleration at that instant, right? That is called it as the acceleration. Now, how do you connect velocity into acceleration? It's the same way, because this is what? This is the slope of the velocity graph is the acceleration. So now if I take the slope, this is I'm plotting velocity as a function of time, then I have a positive slope, right? Positive slope. I have zero slope in here, then I have a negative slope in here. Now what your acceleration looks like? So I should have the acceleration as a positive constant until 20 seconds, and then 20 to 40 seconds, I have zero acceleration here. And then I have negative acceleration to around 50 seconds. Okay. So now these two are related. Again, you can go forward, you can go backward. Forward by taking the slope, backward by using the area under the curve. Okay, so now I think it is very important that you understand the most physical quantities that we are using in physics will be related or will be able to represent by using graphical presentations. So identify the plots are very important, and then analyze the plot will be important, because analyze of the plot give you the parameters that we are interested in physics, right? Okay, so now because of that, we'll take a look on this example. I have variable, the y, change in variable according to the change of x. X is your change in variable, y will change accordingly. So now if I plot the graph, that can be a linear plot, that can be a parabolic plot, that can be a power series. There are different plots that you're going to see, but most of the plot in your class will be linear plots or the parabolic plots, right? We'll say I need to handle the linear plot. So there is a linear plot. So now this linear plot give you the informations that we need, maybe the slope, maybe the y-intercept, maybe the x-intercept. Those informations will be give you some information about the experiment, physical parameters that we're going to measure. So now first thing is understanding the slope. Slope is basically, you can say, rise divided by run. That is the slope is, right? So you take the rise, that will be y2 point minus y1, and you're going to divide that by x2 minus x1, that will be your slope. So this will be the slope, and that also will be equal to the tangent of theta. Why? Because in this rectangle, tangent of theta will be opposite over adjacent. So that means rise over run. That is another way to think about the slope, right? So now we know how to calculate that if you want to do it. But in experiments, sometimes we use the graphical software, maybe Microsoft Excel or some other lab view, some kind of graphical software, right? So in that graphical software, there is a chance for you to do the curve fit. Curve fit will give you the equation on the chart. So you need to analyze what that equations show to you. What are the coefficients parallel? What are the coefficients related to your physical quantities? So now if it is a linear plot, your equation on the chart will be looks like that. So you have y-axis, you have x-axis, and the coefficient you have in front of the x, we call it as the slope. And the coefficient that you have after your x, that is the y-intercept, right? So now those information is important for you to analyze the plots in especially in your laboratory and also in your classroom materials. So now you can have the slope, positive slope, right? If you have a positive slope, this is positive slope, this is my left side, okay? So although you see it in right side, this is positive slope, that will be positive. If it is linear, that will give you a positive constant. And then negative slope will give you a negative constant. And you have a horizontal plot. In that case, there is no slope. Slope is 0. You may have vertical lines on the graph that has undefined slope. Okay, so now let's go more into the understanding of the motions to get an understanding about how those velocities change. So now in my graph or my chart in here, I have a part A. You see that my velocity arrows are the same. What that means is my velocity of the car is keep constant. So when the velocity of the car keep constant, you know what will happen. Your acceleration will be 0 in the car. That will be similar to you use your cruise control in your car. That will be acceleration 0, right? So now there is no acceleration. Purple arrows are not there. My purple arrows represent acceleration, red arrows represent velocity. So now if you go to the second one, you will see that your velocity is keep increasing, right? And also distance between each successive seconds that you are taking will keep increasing too. So now velocities keep increasing, but linearly. I would say it increasing linearly. When you increase it linearly, your acceleration is a constant. You see that acceleration in here? That will be a constant if you increase your velocity linearly, right? So now my C figure, you see that your velocities keep decreasing. We'll say linear decrease. Then you have acceleration constant, but it is a negative value, right? This will be basically idea about acceleration. That means if we speed up, that means you accelerate the car. If you break down, that will be the deceleration or the negative acceleration of the car. If you keep constant velocity, that will be acceleration 0. Okay. Okay, so now let's move into motion at constant acceleration. This is what we're going to focus the rest of the chapter. Okay, so constant acceleration means definitely when you say constant acceleration, you have 3 plots in your head. What is the 3 plots you should have? Acceleration is constant accelerations. So acceleration can be a constant, right? So that means you have constant value of the acceleration. In this case, I don't know what is the value is, but I have a constant value. That means if I take the slope of that should be a 0. That means it should be a horizontal line on the acceleration plot. But what should it look like velocity plot? Velocity plot should be a linear because slope of this will go to this one. Slope is acceleration, right? So now what the displacement looks like, displacement should keep increasing, but not linear, should be a parabolic increase. The slope of that will give you the velocity, right? This is how these 3 things related each other. When I say constant acceleration, this will be the looks like the 3 plots that we discussed. Okay. Okay, so now let's move into the constant acceleration problems. When you have constant acceleration problems, we call it as kinematics that we can solve by using 3 kinematics equations. These 3 kinematics equations you need to understand very carefully, and these 3 will be used to solve the problem which has constant acceleration problems. That means force involved in, I'm not able to use those equations. That is belong to dynamic that we're going to discuss in next section, next unit in your class. Okay, but this is the kinematics part. It's very important that these 3 equations, understanding of 3 equations. These 3 equations can be easily derived by using the information that we discuss. Displacement, acceleration, velocity. Those information is good enough for us to derive those very simple derivation. If you want, you can go to the textbook and take a look. But my interest in here is actually using of these 3 equations and understanding of these 3 equations. So now it's very important that you know we are working with 1 dimension in here. I wrote those all the equation towards x direction. Different textbook, they use different symbols. And people, they use different symbols. But I think this is the best or the most convenient symbols that we can use. Because of that, I expect you to use those equations, not the equation you learned earlier or not the equation you refer to other textbook. Those are the symbols I want you to use. Okay, so now let's go to the first equation. What the first equation says to you. So x final. I am writing those equation towards x direction. That's why I have x, everything is x, you see. X, right? Is all the x you need to change into y direction when you use it for the vertical motion. So I am going to work with the x direction here. Because of that, I have it in x direction. So now my first equation, there is no order of this equation. You can call them different orders. Right now, I'm going to say equation number 1 is this one. So now I have Vx final. Vx final means if you have an object, you start with initial velocity, we say x direction initial. This is what the initial velocity means. After some time, after time interval t, velocity of this ball will be Vx final. Wherever you choose initial and final will be the letters x initial velocity and x direction final velocity, right? And then if you go to the first equation, acceleration ax will be acceleration towards x direction. Time is just time does not have the direction. Okay, so now second equation, again you have v x final, v x initial, acceleration x final and x initial means position, initial and position of your initial and final places. Okay, and then last equation, everything is known, right? So now important thing is the 3 equation is useful, but sometimes you may need 2 equations to solve the problem. Sometimes you need single equation, sometimes you need 3 of them. That's why we have 3 equations in here. Excuse me. Okay, so now let's move into the more information about that. Solving problem, that's the main part of the our class. So it is very important that you follow these rules, because your points or your grade will be given according to your process, not to your final answer, right? I need to understand your process especially. So first thing is draw a diagram, cartoon, that will explain the your problem, and that will show you your coordinate system. That is very important. Everything that you are doing after that drawing should consist with what you have drawn, right? Because of that, read the question carefully, draw your cartoon, and then you're going to write your known quantities and unknown quantities on your diagram, and then think about what physics you're going to apply, and then plan your approach in your head first, and then you're going to write the equation, and then start solving your problem first algebraically. Algebraically means by using the symbols, and next by plugging the numbers to the final answer. Okay, so after you calculate the answer, make sure you check significance as much as possible, accuracy as much as possible, and units. Especially units is very important. And then you can, if you have time, you can go backward calculation and check that your result is correct. Okay, so now those are the important parts. Okay, now we'll see, I have a simple question in here. So you're going to do a problem solving session. We have separate 2 hours for that. This is your 50-minute class. I should explain only the concept, but I want you to start doing some problems here. Then you will be able to get effectively your recitation session. So now first read the question. How long does it take means it is asking time. And then I have 30 kilometers wide intersection. And if a car accelerates from rest, that important information, and to a constant acceleration. That means definitely you need to think that this problem is belong to kinematics, that you will be able to solve by using 3 kinematics equations. So first thing, we're going to draw the diagram. So you can draw the object, right? Car, you don't want to draw the car, you can draw an object that we always use as ball or the rectangular shape. So I have object in here and there is a color light here, right? So now you're going to start in here and this is where you're going to end up, right? So now you need to choose the coordinate system first. Choosing coordinate system is very important in this one. I only have the x direction, but if I measure something in x direction, that will be a positive. If I measure something in y direction, that will be a positive. If I have anything backward or downward, those will be negative quantities. That's what the coordinate system do. Unless you draw that, your problem solving that you are doing has no meaning. Because of that, make sure you do it. And then next step is we need to write down the known and unknown quantities. I'm going to do it on the diagram. You're also going to do it on the diagram. So now we're going to start at this point. That means my x initial will be 0. And also I start at rest. That means v initial in x direction also 0, right? And then you're going to move some time in here. That's what we need to find it out. And the acceleration in x direction will be constant, that is 2 meter squared second. And then you go to the final place and write the information. X final is a positive number that is given 30 meters intersection, right? And then we need to find out the time. V final x final x. It's not given any information. Also, it's not asking you, nothing to worry about that number, because if it's asking, you may need to calculate it. Otherwise, you can just leave it, right? So those are the given informations, right? So now, according to the given information, next step is what physics applies, plan approach to the question. So what physics applied? There is no any other information. This is constant acceleration problem. Definitely kinematics is the one I have to use. Okay. So now plan approach. Approach means I have 3 kinematics equation. Which equation should I use? So now go back to your kinematics equation. So by watching the given informations and by watching those equations, which one you can use. So now let's go to the first question. Keep thinking what you have it in there. I have those information, initial information, final displacement, and time is asking and acceleration is given. So now go back to this equation. First equation, there is time, unknown time don't know, and also x final don't know, x initial known, acceleration known, but there is 2 unknowns that I cannot directly use that equation unless I plan to solve 2 equations. Okay, so now let's go to the second equation. So now in second equation, v final unknown definitely, but every other thing seems to me known. And also problem is I need to find the time. There is no information about the time in the second equation. Because of that, second equation is also not useful to find the time. So now let's go to the third equation. Do I have enough information to find the time? Yes. So that means your third equation is the best equation that you can use to solve this problem easily. There are many, many different methods that you can solve the problem, but finding easy way is your practice. Okay. Okay. So now we decide what to use. So now we know that we can use x final equal x initial plus v initial x direction time plus half acceleration x direction and time power 2. So I'm going to find the time in this equation. So now this equation, you see that it is quadratic equation. If initial velocity is not 0, this equation may not be a good way to solve the problem, because then you're going to solve the quadratic formula. It will take a lot of time for you to solve it. Then you go back to the other equation and check that is there easy way to do it. Okay, so that's the important thing. So now we decide this equation already. So we're going to use this equation towards x direction that match with my coordinate system that I have drawn in there. Okay, so whenever you write down the equation, write the first equation as it is, and then try to make the equation simpler, only put in the variable that are 0. Don't plug the numbers for the other things. So what I know is x initial was 0, v initial was 0, then I put them into the 0, and then I'm going to rewrite this equation, x final equal half acceleration x and time power 2. Need to calculate the time, find it, solve it for the time first. That will be twice of x final divided by the acceleration x and root of that. Then this is the time for you to plug the values. Equal 2 times x final, as I remember, 30 meters per second, and this will be 2, and take the root of that. You're going to get the time in second. Time in second, don't know, 5.08 is the number that I get. Okay. Okay, so now unit second is correct. And your sig fix, you know that your 30 has 3 sig fix, 2 has 3 sig fix. This 2 is a constant, this 2 is constant. Constant, we do not count the significance. Now I should have 3 sig fix. That will be my correct answer. Okay. So you can go back and plug the time into this equation and check your x final is 30. That will give you the more information or your correct value that you can double check that. Okay, so that you can do it yourself if you have time for the problem. Okay, so that will be the way that you need to solve the problem. Okay. Okay, so now let's move into the last part of the section. So pre-falling object. Pre-falling object will belong to constant acceleration problem. That means it is kinematics. So now what is the pre-falling means? So that we need to understand. So pre-falling means any object moving freely under the gravity, we call it as the free fall. What that means? So under the gravity means everyone has the kind of attraction to the center of the earth. That is, we call it as the gravity or gravitational acceleration that is mostly constant in some area. Like with the altitude, it will be changed. With the equator to the pole, it will change a little bit. But we're going to take it as a constant. Especially in New York area, we have around 9.80 gravitational acceleration. That's the number, but it will be pointing towards the downward direction, towards the Earth center. That's the direction of 9.81. The textbook, you're going to find 9.80 value as g, but acceleration has a direction that should be a negative number. Okay, so now let's understand this pre-fall that you're going to do it on your laboratory. So we have some object. You cannot observe this by your eyes because it's a very fast motion that we have 9.80. Acceleration is going very faster that we are not able to even take the picture of that. So that will be hard to do. That's why we have a gravitational acceleration setup, that pre-fall setup that we can use and analyze those results. Okay, but important thing is if you drop it, that means you start with initial velocity 0. So now what will happen when you drop the object? Your velocity going to be keep increasing downward direction. Velocity is keep increasing in downward direction linearly. We're going to increase linearly downward direction. And at the same time, your acceleration in y direction going to keep constant, that is 9.80 meters per squared second. And then your displacement of this ball, you see that displacement in y direction keep increasing, but it is not linear because you remember that the constant acceleration problem, your displacement is parabolic increase. right? So these three things are the things that we have it on your kinematics 3 equation that will represent that velocity is linear, y is parabolic, acceleration is constant. Because of that, this pre-Pauling object will be belong to kinematics solution, simple example. Okay. So now, pre-Pauling objects, we're going to ignore air resistance at this moment because if you do this experiment inside the vacuum, it doesn't matter you have a ball or it doesn't matter you have the paper. So these two going to fall down exactly at the same time on if you do it on vacuum. You see here, vacuum, right one is the vacuum, left one is with air. So that means air resistance will affect to slow down the motion. If you have a paper like this, it will slow down the motion. But if you have roll it up and drop it, they may going to go on the same time. So now we're going to discuss the problem with the absence of air resistance. Free fall motion we're going to discuss with the absence of air resistance. You remember that when I say the kinematics equation, I told that there should not have external agent that disturb the motion. Okay, so that is this is what the free fall is. Okay, okay, so now little bit about this acceleration. As I mentioned, this acceleration value G is 9.80. It is a number. There is no direction in that number. But when you talk about the direction by using the acceleration, that should have a direction. Because of that, this number is a negative value. Okay, so with the altitude, your G is decreasing. That we're going to talk that in your gravitational universal gravitational chapter or circular motion chapter more detail, and G varies with the latitude, right? And also this value in our calculation, we're going to take it as a constant, that is 9.80. Okay, so don't confuse, this G is gravitational acceleration, not the grams. Okay, okay, so now suppose that I have a problem. So problem, ball drop from tower, and again ignore their resistance. So now keep remind what you have to do. First thing is you need to draw the diagram, right? So I'm going to draw it by side in here. So you're going to drop the ball. Here's the ball. You're going to drop it. When I say drop, I have V initial, but I'm going to use the Y direction because this direction of the motion will be Y direction. Y directional motion. Because of that, all the equations I need to use on Y direction. Now, as soon as I decide that I need to label my coordinate system, anything I measured upward direction from this, I'm going to say positive. Anything I measured in this direction, I'm going to say positive X, right? That means this is where that I'm going to start initial. And also I know my Y initial at this point is 0. Okay. So now you're going to drop the ball, and how far it will fallen after 2 seconds. So how far it will fallen after 2 seconds. How far means it's asking basically Y final. Okay. So now your ball will be here. That is your final position. So now V, it does not ask the V in the first case, but I'm going to write V final Y we need to find probably later. And but question is asking Y final and time related to that, and time is given, write it in here, time equal 2 seconds. I did not have correct sig fix in there, but just write 2 seconds. And then in addition to that, we know the acceleration in Y direction with the negative sign 9.80 meters per second squared. So now those are the given informations and everything set up now. Now, according to that, I'm going to decide which equation to use and then solve the problem. So now I'm going to write down these 3 equations. You don't have to write down all equation always, but since I need to go back and forth, I'm going to write the 3 equation in here. Y final equal Y initial plus V initial Y direction time plus half acceleration Y direction time power 2. That is one equation. And V final y direction equal v initial y direction plus acceleration y direction and time, v final y direction squared equal v squared plus twice acceleration y direction y final minus y initial. Those are the three equations in y direction. So now let's move into my first question. First question is asking how far ball is fallen after 2 seconds. So now time is given, I need to find y final. So now which equation will be useful including time and the y final? So that will be definitely your first equation. Then you go here and write your first equation in y direction that will represent that I follow in my coordinate system, and rewrite your equation in here. And then if something is 0, you can make them 0 at first time. This is 0, this is 0, but I need other variables in there. Then you're going to rewrite your simplified equation for the problem, ay and time power 2, right? So now since asking y final, I can plug the values. Half acceleration, make sure that you use the sign correctly, 9.80, and time is 2 seconds and power 2. And then you're going to calculate the y final. Definitely I will get the negative value because your y final is now downward direction. So now this will be basically 2 times 9.8. That will be around 19.6 in units meters. Okay, so I did not have correct sig fix in time. That's why I have incorrect sig figures here. If you want, you can make this probably 2.00 second. Then you have 3 sig fix. Let's use that 2.00 seconds because that make more accurate to your answer. Okay. Okay, so now what will be the velocity at, it should be a velocity, not velocities. Velocity at 2 seconds. Okay, so same information, you need to find the velocity. Now, which equation I can use? Now, I found the y final. If I want, I can use third equation. But do I need to use the third equation? Probably not, because if I do the mistake in first case, then using third equation make another mistake. So without doing that mistake, I can go to the second equation, but it is totally up to you. You can use third equation, or you can use second equation to solve the problem. In here, I'm going to use the second equation in y direction. So v y final equal v initial y plus acceleration y direction and time. So since this is 0, I can make it 0 and rewrite the equation v final y equal acceleration y and time. So then acceleration y is 0 and time is 2 seconds. And then you're going to get the velocity, v final y equal, I think this again 19.6 meters per second. Always box your answer, then when I grade it, I know that what is your final answer. Okay. So now what will be the answer if you throw the ball with an initial velocity, we'll say downward direction, not upward direction. You throw the ball downward direction with initial velocity 3. Now, what's the difference? You still have the same question, right? Same time, same question is asking, only different is your initial y velocity is now 3. Then you go back to your equation in your first equation. Definitely you can use the equation y final equal y initial in y direction and plus v initial y time plus half acceleration y and time. But this part is still 0, but this one is not now 0. You need to plug the value into this all, and then you're going to calculate the y final. Same thing for the second equation. You need your velocity is not 0 in this case. You do the same calculation by using 3 meters per second as your initial velocity. Okay, so now that's the end of the section, so now make sure that you do the problems in your recitation worksheet problems, and also find some more problems in your textbook and solve. That is the only way that you can experience on those problems. That will be very helpful for you to do different or variations of the problems.